In the last video, we implemented numerical differentiation in Fortran. Now we'll do the same in Python, demonstrating how the same task can be accomplished in different programming languages using the same pseudocode or flowchart.
In this Python program, in line 1 and 2, we write header information with objectives, author, and date. As we work with trigonometric functions, we need to import the math library in line 4.
In Python, we define a function using the def keyword, followed by the function name and parentheses containing any parameters and a colon. All function code must be indented and return something using the return keyword. Here, the function fx takes a single argument x and returns the cosine of x. For use the cosine function from the math library, we use math keyword followed by a dot and the function name like this.
In lines 10 to 12, we read the input values through the input function. This function is convenient for obtaining user input, as it combines displaying a message and reading the input in one step. The value entered by the user is returned as a string, so we use the float function to convert it to a floating point number. The program waits for the user to type a value and press enter. In line 10, the user enters the value of x, in which the point we want to calculate the derivative. In line 11, we could ask for the value of h, that is, the increment used in the finite difference formula.
Alternatively, in line 12, we can read both x and h in a single input prompt through the use of the map function, combined with the split method. The split method divides the input string into a list of substrings based on the comma delimiter. The map function then applies the float function to each substring, converting them to floating point numbers. Finally, we unpack the resulting values into the variables x and h. This approach is efficient when we want to read multiple values in one go.
Maybe the use of map is a bit abstract at first glance. Let's unravel this idea with an analogy and some practical examples. Let's imagine an iterator as a factory of values on demand, in which an iterator acts like a factory that doesn't produce all its products at once, but rather on demand. When you request a product, the factory produces and delivers it. When you request another, it produces and delivers the next one, and so on.
But why use iterators?
The answer is memory efficiency. If you have a very large iterable, calculating and storing all the results at once can consume a lot of memory. Iterators avoid this problem by calculating the results only when needed. Iterators are ideal for processing data that arrives in a continuous stream, such as data from a file or a network connection.
Finally, in line 14, we calculate the numerical derivative using the finite difference formula, as shown in the image to the side. We use the function f(x) twice, once at x plus h and once at x, subtracting the two results and dividing by h-bar.
The result is printed in line 15 through print function. The f token before the string indicates that it's an f string, which allows embedding expressions inside string literals using curly braces. The expressions inside the curly braces are evaluated at runtime and formatted according to the specified format.
To execute the program, we type the following command in the terminal: Python 3 numdiffy. The program will prompt us to enter the values of x and h. After entering these values, the program will calculate and display the numerical derivative of the function at the specified point.